Let's discuss about that Linux file system. So Linux file system often referred to as the Linux file system hierarchy standard, which is FHS. So basically it's a structure and like organization used for that storing and managing files on Linux based operating system. So basically it's defined like how files are accessed by users in the application. So the Linux file system is like hierarchy or like meaning it is that organized into a tree like structure with the directories, and in directories we can refer as the folders in like at various levels. So the root directory is denoted by that slash, so it's the top level of directories from which all the directories and the files stem. So Linux file system structure, it's like we can divide into that three layers. The first one is that logical file system, second is that virtual file system, and third one is that physical file system. So logical file system like acts as the that interface between the user's applications and the file system itself. So it facilitates that essential operations such as that opening, reading, and closing files. Essential, it serves as the user's friendly front end and ensuring that applications can interact with the file system in a way that aligns use that users' expectations. But in virtual file system, it's a crucial layer that enables the concurrent operations of multiple instances of physical file system. So it's provide a standardized interface allowing different file system to coexist and operate simultaneously. So the layer abstract the underlying complexities and ensuring compatibility and cohesion between that various file system implementations. Then number three is for that physical file system. So the physical file system is responsible for the tangible management and storage of physical memory that blocks on the disk. So it handles the low level details of storing and retrieving data, interacting directly with the hardware components. So the layer ensure the efficient that allocations and utilizations of physical storage resources, contributing to overall performance and reliability of the that file system. Let's discuss about that multiple types of that file system. So first one is that ext, which is extended file system. So ext is implemented in 1992 and it is the first file system specifically designed for the Linux, and it is the first member of the ext file of that file system. Then ext2 comes in the picture, which is the second ext was developed in which is 1993, and it is a non-generaling file system that is preferred to be used with that flash drives and an ssd. Then it's XIFS, which is also developed in the same year, which is in 1993. The file system was less powerful and functional than that ext2. Then ext3, which is third ext developed in 1999, which is again a journaling file system. It is like reliable and unlike that ext2, and it prevents a long delays as system boots if the file system is in inconsistent state after that unclean shutdown. Then JFS, which is Journal File System, which is first created in IBM in 1990. The original JFS was taken to open source to be implemented in Linux in 1999. So JFS performed well under different kinds of that loads, but it's not uh, that commonly used anymore due to that release in ext4 in 2006, which gives better performance. Then it's xfs. So xfs is basically that 64-bit journaling file system and was ported to that Linux in 2001. So it is now acts as the default file system for like many Linux distributions. It provides that features like snapshots, online defragmentations, that sparse files, variable block size, and excellent capacity. And it's also that excels at parallel input-output operations. Then ext4, which is like the fourth ext developed in 2006, and it's a journaling file system and it has backward compatibility with ext3 and ext2, and it's provided several other features, some of which are that persistent pre-allocations, unlimited number of subdirectories, metadata checksumming, and large file size. So ext4 is the default file system for many Linux distribution and also has compatibility with Windows and Macintosh. Then there are some others also like BTRFS and that BCSFs and like others file system also like NTFS and EXFAT, but these do not support standard that Unix permission settings, and they are mostly used to like interoperability with other operating systems. Let's move in the directory structure. So as discussed it earlier, that file Linux system is installed in directly in slash. So slash is like that root file system. So it's a top level file system directory, and it is must include every file needed to boot the Linux system before another file system is mounted. So every other file system is mounted on a well-defined and standard mount point because of the root file system directories after the system is started. Then that slash boot. So it is included static kernel and bootloader configurations and executables files needed to start a Linux computer. Then that slash bin. So this directory includes that users that executable files. So when we start that Linux privilege escalation, you will understand that why we are that searching in that bin folder or the boot folder, or why we got that some misconfigured files. So you have to learn about these that directories. And next is that slash dev. So basically it's include the device file for all hardware devices which are connected to the systems. These are not the device drivers. Instead, they are files that indicates all devices on the systems and provides access to these devices. The next is that slash etc. So basically it includes the local system configurations file for the host system. Then slash lib, it's includes that shared library files that are needed to that start the system. Then slash home, the home directory storage is available for that users files, and all users have a sub directory inside the slash home directory. Then the MNT. So MNT, it's like we can say the temporary mount point for basic file system that can be used for the time when the administrator is working or repairing a file system. And slash media, which is a place for that mounting external removable media devices like USB thumb drives that might be linked to the host. Then slash OPT, it contains that optional files like vendor supplied applications program that must be placed here. Then slash root, it's the home directory for a root user. Keep in mind that it's not the slash file system, it's a name of that user, that slash root. Then slash tmp, it's a temporary file directory used by that operating system and several programs for the storing the temporary files. Also users may temporarily that store files here. So remember that the files may be removed without prior notice at any time in this directory. And slash asbin, so these are the system binary files and they are executables utilized for that system administration. Then slash users, and they are like read only and that shareable files including executables, that libraries and binaries. So main files are several documentation types. And last is that slash web, and here variable data files are saved, and it contains things such as that MySQL log files, other databases files, email inboxes, that web server data files, and much. Then let's move into that mounting in the Linux file system. So in Linux, to mount a file system term, which is referred to that initial days to computing, uh, when a removal disk or a tap pack would physically need to be mounted on a correct drive device. So on the disk pack, the file system would logically be mounted by the operating system to make that contents available to access by application program, operating system, and users after being located on the drive physically. So simply A mount point is a directory that's made as a component of the file system. For instances, the home file system is placed on that slash home directory, and file system can be placed on a mount point or many non-root file system, but it's less common. So the root file system of Linux is mounted on the slash directory, that means the root directory. Remember, I'm not talking about that root user, only that slash. So it's very early inside the boot sequence, and that several file systems are later that mounted by the startup program of that Linux, either RC upon that system V or via system in that Linux versions. So file system mounting that during startup is handled by that configurations file like etc fstab, and as easy way to understand that is fstab is short for that file system table, and it's a file system list that is to be mounted their options and design mount to points that may be required for particular that file system, and file system can mount it on a available mount points directory with the help of that mount command. So in other words, any directory that's applied as a mount point shouldn't have that other files, and it is should be an empty. So Linux will not be avoid users from mounting a file system on that's already available or on a directory that includes files. So the actual contents that will be covered, and just the freshly mounted file system content will be visible if we mount any file system or any existing file system or directory.